Okay, here's our third and final example for the notes. It says, let R be the region in the first quadrant bounded by the graph of y equals this quadratic function and the horizontal line y equals 1. So we're talking about this white space in here. And it's the base of a solid. So if we're looking at our birthday cake from the top view, that's the shape that it's going to take. But the cross sections are semicircles. So let's see what that's going to look like. I made 4 of them this time, overachiever. So from the side, it's going to look like a series of rectangles, circles, semicircles. So you see how that looks? And I made 4 of them, but we're supposed to imagine that there are just hundreds of them, so it fills up the entire solid. Okay? And I want you to pay special attention here, because do you notice that from this side to this side, that's not the radius. From the center of a circle to its outside point, that's the radius. So we're really looking right here at the diameter of our circle, and that's going to come into play when we do these problems, okay? So let's attack the problem like we attacked the other problems. The first thing we got to remember is that the volume is going to be the antiderivative of the area. So what was the shape it asked me for? It asked me for a semicircle. And fuzzy wuzzy was a bear. Area of a circle is pi r square. So a semicircle is going to be half that, so pi r square over 2. But like we said, notice that it's the diameter that's the base of my solid. So I'm going to go over here and just look at this really quickly one more time. See all these shapes? We're looking at a semicircle, but the distance between the two equations is the diameter. So how do we find a radius? We do diameter divided by 2. So instead of saying that the area is pi r square, we have pi over 2, and then the radius is d over 2, and we got to square that radius. So what is d over 2 squared? It's d squared over 4, and let's distribute. So we get that the area equation is pi d squared over 8. So again, I told us it was a semicircle. A semicircle's equation is pi r squared over 2, but because our cross section has our diameter as the distance between the two equations, we have to find diameter divided by 2 as the radius and plug that back in. So there's our equation of the area. Okay? Now the next thing we have to do, is this a perpendicular to the x-axis or a perpendicular to the y-axis? Let's go back and look at the problem. Perpendicular to the x-axis, so that means we're on this side of the bar. So when we're trying to figure out what the diameter is, I'm going to go back to my picture here. The diameter is going to be whatever this top equation is, which is the parabola, minus this bottom equation, which is the y equals 1. So we say the diameter is the top minus the bottom. So the top equation is the parabola. The bottom equation is 1, and that is our diameter. So let's go to solve this problem. The volume equals the lower x bound to the higher x bound. Put the formula in, pi over 8 d squared, and what do we say the diameter was? This top equation minus this bottom equation. So that's what I have in here, dx. I got to tell you, when I put this in my calculator, I don't bother to type all of this in again. I put this equation in y1, I put this equation in y2, so that way I can just go from this equation to this equation, pi over 8, parentheses, y1 minus y2 squared dx. So you might be wondering, couldn't I have just put plus 4 here? I could have, but y1 minus y2, it just made it easier as a calculator problem. And then I go ahead and put it in my calculator, and I get the answer. So once again, what's the shape? Write the equation for the shape, figure out what makes it special in this problem. In this particular case, we are not looking at the radius here between the parabola and the line y equals 1. That distance is actually the diameter. So the radius is the diameter divided by 2. So that's why we had to put d over 2 in place of the r and distribute everything. We get our area equation. We figure out that this is a top minus bottom sort of thing, and that makes the diameter the top equation minus the bottom. We put it in our equation, in our calculator, the lower x bound to the higher x bound, pi over 8 d squared, get our answer. That's 3 examples of volumes with known cross sections.